Welcome back to Capturing the Intangibles. This week we bring back Sir Manju Ganamasti to talk about monolith versus microservice architecture and why in the world should it matter to business leaders what's under the hood of their cloud systems. Let us know your feedback and don't forget to subscribe. Let's get into it. Hello, gentlemen. Welcome back to another edition of Capturing the Intangibles. We've got a super exciting topic on the agenda today around modern architecture and how right architecture should be important to the business. And it centers around this growing practice of microservices and moving away from what's called a monolith architecture. But let's just get right into it. So, Manju, our guest of honor, you've been here before. You're much smarter than all of us. Let's start with you.
Sure.
So, what does it really mean when we say a monolith architecture? And give us a technical description, but then how would you describe that to a C-suite?
Sure. So monolith is basically an architectural pattern where you combine multiple components into a single deployment package, and you build and deliver and deploy and run as one or more deployment packages. So there can be multiple components in the same build, right? Deployment. So one is there could be UI, there could be the backend, or there could be APIs, etc. All of them packaged into a single deployment. It may be a WAR file, or it may be an IIS site application, etc. And from the management standpoint, it is easier. But if you go to scale it in the multi-tenant cloud, then it would be harder to manage it, right? Because you package all the functionality into fewer deliveries or fewer packages.
Yeah, so that's interesting then. So Manju, can you go into a little bit more detail? And well, actually, for both Massimo and Manju, you guys have been doing this for such a long time. You've probably seen every single phase and trend that's been going on in terms of how to actually develop and architect an actual product. But can you go into a little bit more depth about why our monolithic architecture is actually a challenge and something that we should be looking to avoid as vendor developers, but also as customers looking at this?
Yeah, I can give you maybe the business perspective, and Manju probably is going to give a little bit more technical perspective. I think that the problem we have today is if you are a CIO and you go to your IT department and say, hey, we're going to a new business, right? I need new functionality. Um, can we do that today? Because we need it today. The business always needs things today. And so the reaction to that from an IT perspective, you see that the business asks, the IT delivers maybe in 1, 2, 3, 4, 6 months, 1 year, and so on. And so the less flexible the architecture is, the longer the business will have to wait. The more flexibility will have the architecture, the more speed you will have to change things to what the business ask and then deliver back to for that. So if I'm looking for breaking a monolith from a business perspective, what I hope is to get more speed and agility in getting functionality that I need, right? Because the business change, with the pandemic, nobody predicted the pandemic, but now all of a sudden there is a pandemic. Can you react to that, right? So that's actually what I'm looking for. And historically speaking, monolith architecture has been very unflexible to react to these changes.
Thanks, Massimo. So
Yeah, Manju.
from our perspective, right, I will go through our experience, right, and our journey. So for when we were focusing mainly on on-prem, right? So we had to package and we had to be as nimble as possible, and also our hardware requirements had to be as minimal as possible, and our load requirements were quite low, right? So maybe 5,000, 10,000 users is high end, or maybe 50,000 users max, right? So that being the requirement, and also customers would like to spend as minimal as possible on the hardware, right? So we had to package all these things into a smaller footprint, right? So we are not asking for like 128 GB memory or 64 GB memory. So it had to be like 32 or 16. That's like high end about 8-10 years back. So that was working fine, right? Now when we have transitioned to multi-tenant cloud, you are looking at 5 million users accessing the system, right? And hundreds of thousands of concurrent users accessing the system. So what happens is each component has a higher load, and you need to break it down so that first of all you can develop and manage it easily, and also you can scale, because some component may require higher scale and some component may not. So you should be able to scale independently so that you don't have to scale the whole thing. And monitoring perspective also, you want to monitor independent. Each item, each component becomes critical, and you need to be able to monitor each one of the components, right? So there are multiple factors that come into play. If you have a small scale application, if you have a company with like 200 users, and you want to deploy a microservice architecture with many services and lot of interconnections between them, then it becomes a overhead, right? Microservice will not be an advantage, it becomes a disadvantage, right? But as the scale is increasing in the multi-tenant cloud, so there is more incentive to move to microservices architecture than keeping the monolith. But on the other hand, if it's small customers, there is always incentive to keep it as minimal footprint as possible, as low maintenance as possible, and so that it will be beneficial to manage that infrastructure easily.
So if I understand you, Manju, if you say if you have a monolith, the monolith you can scale it, but you can scale it only one way. If you have a more broken down architecture, and as scales comes up, you can take pieces of functionality and say, I need more scale or more volume on this piece. You can give more volume to the pieces, while the others doesn't need per se more scaling, right? A printing job, or more user logins, or more an integration or an API calls. You can now to define flexibly how you're going to scale, and do it even differently, because it's going to be optimized for that use case. That's one of the big advantages of breaking the monolith, right?
Yeah.
I think that's what you were saying.
Yes.
Okay.
Manju, is there a cost benefit to that though? So if you're able to scale different aspects of these different services, is there a benefit to the business to say that, well, hey, I might be able to offer a better price point because now I'm only using certain aspects of the system to where I'm not having to scale this huge thing,
Yeah.
right? So is there a cost benefit to this?
Yes, definitely. So there are multiple dimensions of the cost benefit, right? One is uh, the ability to pinpoint the services that need to be scaled out, right? You don't have to scale out the complete infrastructure. There may be 100 different subcomponents in a monolith, right? And if you need to scale it, you need to scale the whole monolith, right? So the footprint for the memory and CPU would be higher, right? But in the case of a microservice architecture, you are scaling at individual microservice level, right? So for example, in the morning and in the afternoon, let's say it's like their users are logging in and logging out, the single sign-on system and authorization systems will be at a high usage in the beginning of the day. As the day progresses, so there will be minimum load on those systems, there will be higher load on the business applications, right? So you can control which system can be scaled, and you can control these things to scale up automatically and scale down automatically, so there's reduced cost, right? That's one factor. So you don't have to scale all the services and scale down all the services. You have that control. The second factor is about the serverless as well. So with all these things, so we'll talk more about the serverless architecture at a later time. But with serverless architecture, that's another dimension of the benefit, where you don't need to have anything running. So that means on weekends and on holidays, let's say there are no services that are used, you want to be paying as minimal as possible, like zero actually. So effectively zero, other than the database. So compute wise, you don't want to pay anything, right? That will be a huge advantage, right? So that those are some of the
Yeah.
factors for cost.
Yeah. So Manju, you were saying that if it is smaller, it's okay maybe to have, I would say, more monolithic architecture. As you start to scale, you want to scale differently. Yes, microservice architecture is going to be good. But you were talking about overhead, right? So where is the overhead of a microservice architecture? Can you give some examples?
So overhead of a microservice architecture is, first is, you are managing these loosely coupled components, right? And you have the developers managing them, and these services need to be wired, they need to be connected. And as you go with the microservices architecture, there is integration issues that come up between the microservices. So that means that you need to, there may be a network issue or there may be some connectivity issue. So you need to be able to monitor all those components. Let's say you have 25 microservices and they are interacting with each other, right? And if there is any connectivity, you need to be able to put the services in place to be able to monitor them and address any issues that come up, right? But if you go to a small company and then you, like, there are like 50 users and then you put like 25 microservices and they have communicating, and you tell them, oh, we need to put a monitoring system and to monitor the connectivity and take appropriate actions. So those can become an overhead in the management, right? If those were using the previous models, it may be beneficial, right? And we can run it with low footprint, because if you talk about Java, you may, for each microservice, you may need about 4 GB of memory. And if you have 25 microservices, that's a very high requirement on the infrastructure. But if you go with the old school of Monolith, then it can have a very low overhead from the hardware standpoint, and it can have a very low overhead from the maintainability standpoint. So it depends on the scale. So if your scale is higher, if you are doing like 300,000 SSO requests per hour or something like that, then it is a pretty big chunk that needs to be managed and monitored independently. But if you have like 20 or 50 or 100 single sign-ons happening every 10 minutes, so it's not a big deal actually. So it can be built as it can be packaged as a monolith and delivered, right? So those are the overheads. One is the hardware overhead, and also the second one is the maintainability overhead.
So, but I would say, just a good Italian joke. So the microservice architecture in the cloud is not a new spaghetti architecture, or is a new spaghetti architecture?
Uh, so it's not a good idea to take the monolith architecture to the cloud, especially when you know that your load is going to be high, right? So
Hmm.
it is going to be ending up as a spaghetti architecture, right? In the same terminal, in the same concept, just blindly taking the microservices architecture to on-prem when there is load is low, then it's like you are over engineering the solution, right? So that is over
Yeah,
engineering, right?
yeah,
Yeah.
yeah,
And
absolutely.
there may be products that may have to go to cloud in a very short period of time. So keeping in mind of the long term prospects, like immediately you can move it, but the engineers will find it very soon, and also the business owners will soon find that it is not very easy to scale, or you'll have to pay a very high price for scaling those monolith systems.
So you said something interesting earlier, Mandrew, and this is to all of you guys, but Mandrew, especially you, I'm kind of curious. We've been talking about microservices for as soon as I met you, Massimo. I think you were talking about microservices probably during the interview. But this has been something that you've been talking about for years, right? Monolithic versus microservice architecture, and so on. And the technology has been sort of around for quite a while now, right? Starting with Docker when that blew up, and then you have Kubernetes these days. So Manju, when you're architecting these, obviously there's a lift and shift. There's a change that's driving that embrace of microservice architecture, predominantly cloud, right? A lot of the scaling and automation capability. But you mentioned something interesting about managed services, or more specifically, serverless architecture, which is sort of beyond that traditional microservices approach, or maybe it's not. I don't know. What do you think about that? Because now all of a sudden you have a serverless option where you're not actually having to manage all the scaling, the load up, the load out, and dealing with all that mess and fuss. But you're still an architect that needs to deliver a product and a project on top of that. So has serverless factored in or changed the role of the decision making for an architect, or has it augmented it, or just simply given you more options to solve for the same problem?
It's the last one. It has provided more options, right? The concept remains the same, that a one scrum team or a one scrum team managing a small subset of microservices. There is a specific ownership for the microservice. There is a dedicated team doing that and continuously working on improving those either individual or a subset of microservices. and also monitoring it and operating it as well, right? And they control the roadmap, and it is loosely coupled so that it can be developed independent of the other microservices, right? So those are some of the concepts. Now, serverless is, I would say, is one of the path for implementing the microservices, right? There are many
Hmm.
options. You can have Kubernetes, or you can have ECS or EKS, or you can have Fargate, or lambdas with the step functions, right? So lambdas and step functions are going to the last part, which is the serverless, right? There may be the the lambdas are catching up, right? Very close, right? So now we have very minimal load times, but still for some applications it may still be not enough. But they have come down significantly on the load times. They have come and they have increased the hardware capability of the lambda functions, like how much of CPU and memory can be used. So they are catching up. I would say the serverless is just an option. Even you can say Fargate is also a serverless option. The advantage of serverless versus the with the server is that the companies like us would have to manage that infrastructure if we are not going with the serverless option, right? We need
Hmm.
to identify the vulnerabilities in the operating system. We need to update, patch the operating system. We need to patch the application server, IaaS, etc. But in a serverless option, for example, Lambda, a business application company like ours do not have to worry about the underlying hardware, underlying operating system, and underlying application server to be patched for any security vulnerabilities, etc. Right? And we don't have to worry about provisioning them. We don't have to worry about scaling them. So the cloud provider should be able to take care of scaling out and scaling in the infrastructure. So we don't have to worry about at the EC2 instance level at all, actually. So in summary, it's an option. It's an option which is becoming more and more attractive for architects.
I got a follow up question there because it's interesting because we've been talking about multi cloud strategy too over the past, right? So does being able to adapt quickly to multi cloud requirements, for example, influence the decision on when to use things like Lambda and vendor specific Lambda architectures
Yeah.
for accomplishing a particular platform execution?
So different architects may have different opinions on this one. So if from my perspective, for the you can deploy it two ways, right? So one, you can be packaging it as a Docker image, and you can deploy it on Kubernetes or ECS, EKS, Fargate, etc. Right? So there, the individual developer who built the application is not worrying where it is going to be deployed, right? So there are automation engineers who are going to write the code to see how it can be deployed and run and managed. So there'll be some change there. Effectively, application development is not having significant impact, but the automation engineers would have some, DevOps engineers would have some variations, right? At this point of time, it is reducing, but still it is there. I agree with you. On a solution like Lambda, right? Yes, there is no standardization as of now, right? So if it is Azure Functions or Lambda, but you can always develop your applications in such a way that you can abstract those external integrations with Lambda or Azure Functions, etc. And that's what we are doing with our backend as a service project, right? So we can always abstract it, and but of course, like 98, about 95 to 98%, the application developers would not have to worry about where it is going to run. And there is 2%, one is automation, one is building, another one is writing the abstraction, so that you can run your logic in Lambda or Azure Function, so you'd be able to manage it. So I considering the advantages, so I wouldn't say, it depends. If there is a company that is that is focused on multi-cloud, right, to be able to support all the three major cloud providers, then they may have to put a little bit more effort. But for companies that are not, this especially if it is an IT organization, they know, right? So they are going to be partnered with a specific cloud provider. So then it is it can be an unnecessary overhead to just start thinking about this extra layer of abstraction. They may have another project to just move it to from Azure to Google or Google to Azure at a later time. So at this time, it's not that much of a worry. If you want to implement it, there are ways to implement that abstraction. But if you're not worried about being tied to a cloud provider, I think you could directly go and use the services.
Totally makes sense. Yeah.
Yeah, absolutely.
I think we can agree though between this group here that that sort of multi-tenant, multi-cloud is the mecca, right? I think that's where we would absolutely like to invest our time moving forward, because that's going to put us in a position that makes us so flexible. Again, from the technology perspective and the management overhead, absolutely, but the business benefits behind it. But Massimo, I've got an interesting question for you.
Mm-hmm.
So in the analyst community, you and I have been bouncing back and forth, debating. I believe they call it business capabilities versus microservices, right? More one being more specified to the technical nature that Manju's alluding to, and business capabilities more breaking down of like the business applications. But my question to you is how far can or should that be broken down? Is there a point of diminishing returns, or what is the point to where you say this is where I'm going to stop this because it makes the most sense?
Yeah, that's a very, very good question. And we're debating many times also, among our teams. But I've seen implementation where people went crazy and went from one monolith to, I would say, 1,000 microservices, and then the whole thing doesn't work, right? You really have to divide into the functional components, how you're going to break the product from a functionality perspective. And then behind that specific functionality, how many microservices do you need to fulfill that functionality, right? And I think the best approach is to start to break pieces in smaller. But then let's say you have an ERP. Your ERP is even complex. But then you can say, well, I can have purchasing, sales, inventory, finance with AP and AR. And then you can, even if you are in distribution, if you are also manufacturing, you can have the production side. So if you already take these pieces, there are 6 or 7, and or you take another application, you say, well, I'm gonna break it down in the macro level, and I start to build the microservices that will fulfill that functionality, which is probably not 101 but the 1 to X. um, then you're already breaking down the product in a good way. So my suggestion is always to do a top down from the functionality and see what type of microservices you need, what type of common microservices DevOps you need, because there are things that you're going to share among the modules. And if you feel after the first release that you haven't been going down too much and you need to break it, you can go even further and break it down the architecture. But you always do it in a conscious way, instead of saying I'm breaking the monolith in 1,000 pieces, and then it's like a puzzle, and then you can put the puzzle back again, right? So just do it in good chunks, break it in good chunks that are manageable from a process, people, and architecture perspective, and then take it down from there. I think I would give this recommendation to people. And again, my joke to Manju is the microservices architecture in the cloud, is that the new spaghetti architecture? You can end up a new spaghetti architecture if you really do things in a crazy way. And I've seen really crazy implementations of that. And I think what Mike was saying, I think maybe back then when I interviewed Mike 5 years ago, we had the concept, but maybe we didn't have the technologies yet. But I think now it's a time that you should be starting thinking about microservices and a solution composition as well, right? I don't know, Manju, what's your view on that?
Regarding the spaghetti, yeah, it looks spaghetti, right? So microservice architecture, if you don't do it right, so it's going to be bad. But irrespective, if you do it in the right way, or if you put it on the architecture diagram, it looks complicated, but I think that's the only way to go, right? So that you need to keep into consideration.
I remember when Manju showed me when he was breaking down the portal, and I was like, "Oh, okay." I got like, "Oh," but then you start to understand the pieces and why it's done, and then it's becoming very interesting and very good. But the first impact could be like, "Whoa, wow, this is can be overwhelming," right? So from an architecture perspective.
And just to add, so yes, so you need to be careful about how you're going to break it down, and you need to be practical, and you need to also know what is the load, right? So just because, okay, at this point of time functionally it makes sense to break it down, right? But also you need to see what will be the effective load on it, and what will be the future scalability aspects. If it is one request coming every minute, so then yeah, you may need to management perspective, you may want to consolidate, right? But you need to be
Hmm.
careful, and you break it down slowly, right? For example, if there is a new, if you have an output management system that is generating the documents and printing, let's say the printing use cases are increasing, then maybe you need to break down the printing part from the document generation. So you create a document,
Hmm.
and then you feed it to the printer, and there may be higher and lower load on the printing or versus email. So you need to observe and adapt, right? And most
Yeah.
of the most of the companies, most of the team, there may be a monolith, so you need to break it down bit by bit, right? So that skill is very much needed in that scenario as well.
And it's a journey, Manju, right? So
Yeah.
you can even have a monolith working with some new services, and you start to break it pieces, and that's a manageable project instead of rewriting everything in microservices. And but then it's a big risk. So breaking the monolith meaning is starting to take piece out of the monolith, you rebuild it in microservice, but still have the monolith working with the microservice until you reach a point that you have all the microservices done, right? You
Yeah.
you really have a new architecture. So that's the scalable methodology and safe methodology to bring something to a microservice. So yeah, it's really very exciting, and now we have the technologies to do that, and for sure in the cloud.
Yeah, so let's go back to the business benefits. Now that we've kind of broken it down, how far can we go? What is it, et cetera? And the business, or especially the benefits from the technical overhead perspective. Massimo, you said something earlier that it's more about the speed of delivery for the business. And I think we
Hmm.
should maybe dive into that a little bit more and clarify, because you and I have talked about this like several times in the past where, I mean, our group, we operate at the platform level. So ours is not really all that different. But again, it's back to that business capabilities versus microservices and how far are you taking that. But if you have your business applications that are broken in such a way that allow you to interact with just core capabilities in that ERP or maybe that edge application, it provides that sort of flexibility. So when we're talking about, it's almost like that this, I would argue the microservices architecture has in some way fed off of sort of this API abstraction technique, right? Because if I have the ability to interact with just a single part of my system, now that it's been broken away from the monolith, now I have a lot more flexibility to say, well, this business process doesn't have to always be tied to this one. And maybe you can get closer to that autonomous enterprise experience, right? So I think what you meant by that, and correct me if I'm wrong, is that speed of delivery is that now I can change my business process or even how I interact with my system so much more easily, because that has to be architected in a way at that service level, and that requires prerequisites. Do I have REST APIs, et cetera? Right? Is would you say
Absolutely.
that's
I
in line?
think, yeah, I think what people, they were calling in the also in the past, but that solution composition that people are looking for. So let me give you an example. So let's say you have an asset management system. Something breaks down and you want to order a new spare part. An asset management system has a purchasing, module, right? So you can put a purchase requisition in. But at the end of the day, you need an ERP, because an ERP has the inventory and has the financial module. And so to fulfill the entire process to order a new spare part, you need different other, applications to do that, right? So now, there's two things. I really want to compose that solution, that business process. So I want to say I want the purchase requisition, the PO in the ERP, and the inventory and the financials working all together. So I want to compose that process. The second part is, you can say, well, you can do that today between an EIM and an ERP, but guess what, then you take the monolith ERP all together, and while you only need purchasing and inventorying and finance, you don't need all the other things that the ERP has, right? And then if you want to scale the ordering, like Manju was saying, now you have to scale the entire ERP. Well, maybe it's just the finance thing that you have to scale it because of this business flow. So you see, this example brings already three things that the business wants, but can you respond to this, right? So to this business capability, can you compose a business capability? Can you run it at a cost effective so you don't get a big monolith with you, the things that you're not using? And can you scale it, right? So that's actually I think that's the promise of this new architecture. I hope that this new architecture will bring this type of promises. And by the way, because they are loosely coupled, um, the purchasing system and the finance system may run even another cloud. You know, well, we like everything a little bit together, but at the end of the day, microservice architecture doesn't know about the existence of others. You know, they are self-contained, right? So I can order a new asset from my asset management. I can rely maybe on an info ERP to do the rest of the process. But guess what? Maybe a customer has a different ERP. And well, can I do that composition? And do I have a platform to do that composition, right? So do I have that flexibility for me as a CIO? Those are the things that we are looking for.
Yep. And a couple more points to add on top of what Massimo said.
Mhm.
From the business standpoint, the microservice architecture and the organization that is in alignment with the microservices architecture would help in parallelism in development, right? So the faster you, so for example, there is a business task, there is a business functionality that needs to be built. At least in our case, it rarely goes into just one microservice. There'll be like 4 or 5 microservices that need to be changed to be able to meet that business requirement. So with when you have broken down in this level, you can have 5 different teams work in parallel and also deliver the solution in parallel, and they can deliver the solution to production at different timelines, as long as they have aligned on the feature flags and how they can enable the features in each one of their components. They can build, deliver to production independently, and then you can integration test at once and deliver the solution. So that also provides there is no dependency, interdependency on the teams as to when they will deliver. So that should also help the business in getting the solutions faster.
Yeah, I love this. I really love this concept. And the other question I do have for you, Manju, is let's say that I work in support, right? So a customer calls me and says, "Hey, I got some issues in the solution." How can you debug the execution path in a microservices architecture, right? So it
Yep.
could be that whatever the customer was doing may touch, I don't know, you have a microservice 100, let's say you have 100
Yep.
microservice architecture. So how do you know that what the customer did has touched 50 or 70 microservices? How do you debug that execution path?
Yep. So that's very much true. And every request will go through at least 3 or 4, right? In our case, every request that is coming in will go through at least 3 or 4 microservices minimum, right? And it could be a lot more, right? So you need a set of tools, right? So to be able to identify the issues, right? So one is you need to have a log aggregator, and you need to have the logging from all these microservices consolidate, so that the application developers do not go into each and every logs from each and every microservice to identify a problem, right? And there should be a way in which the requests are identified, so that you can identify a specific request from the client side or at the gateway level, and to be able to trace across multiple applications in the logs, right? Using some application like Splunk or Sumo Logic. The next one is using an application like Jaeger for tracing the requests, right? So that is almost mandatory when you have microservices. When you have many microservices, you basically, for every request that is coming in and going out of a microservice, that is sent to a system like Jaeger to trace it, like using open tracing. That's another requirement, right? And third one is to be able to use monitoring, time series based monitoring, to trace the request, and if there is any logging on the failures, so you have a metric on the failures, so that you can either monitor, or you can have the alerts generated, so that if a microservice goes down, you are immediately notified that there is like, you know that is your success rate. If your success rate of a microservice is goes down below 99% or 99.5 percentile in a specific window, then you have the notification saying that there is maybe some problem with a specific microservice. So you will have to use these kinds of tools to be able to monitor the infrastructure, and you need to have the Sumo Logic queries for each microservice ready to go. So it is a major undertaking if you need to manage, right, let's say 100 microservices. It is quite a bit of effort. And and most of these things coming from the development team, so it's like each the support and the operations would have to be deeply connected with the development to be able to monitor a system and troubleshoot a system as well, right? Because they need to collect all these metrics. What are the metrics for a microservice? What are the sumo logic queries, or Splunk queries for a microservice? And to have these kinds of queries aggregated at different level, like at a request level, and to be able to go into a system like Jaeger to see the trace the request going through end to end from one microservice all the way to the lowest level or foundational microservice, right? And in the same time, so you need to have the proxy, the NY kind of proxies sitting on either side, right? So sidecar, you'll have to use the sidecar pattern, and the implementation is like NY. Use them on either side of the application, so that if there is any failure, if one microservice at the third level is failing continuously, there may not be a need to make a call to that third microservice anyhow, because it is like last 5 calls have failed continuously back to back. There may not be a call, so you don't even make a call and you respond back with a failure till that connectivity is established, right? So those kinds of toolings are also important in the architecture for you to be able to successfully monitor, right? And definitely the development team plays a critical role in defining these things. And the development team, from the organization standpoint, development team will have to work closely with the operations as well as the support. So they should act as one team in monitoring the system.
Great answer, Andrew. Before we kind of close this out as well, I had one question to kind of put a point on this to you, Rick, because the whole concept is capturing the intangibles. So this is like the intangible, right? The thing that no one ever really understands when they're actually using cloud software, but it's a really, really big piece of solutioning and design, at least on our vendor side. And we were starting to dance closer to this, talking about functional capabilities and functionally leveraging some of the the benefits of these types of architecture decisions. But as an IT director, decision maker, CIO, how do you actually qualify and actually help someone understand the importance in making a technology decision? And how do you actually say that a microservices architecture or even an architecture decision in one direction or another is meaningful for an IT decision maker to actually understand when they actually do need to execute a build versus buy decision, or which vendors they're going to select for? How do you distill that down and actually say to someone, this is why you should be asking these questions and why it's important to you?
Yeah, that's a great question, Mike. And I would start by saying we've developed that just through our experience, right? Like the technologies that have been available. If we would have known that this was our path 5, 6, 7+ years ago, we would have probably started completely differently. But I think what we've seen is that as we move further and further down what we're calling like this disruptive innovation path, and let's qualify what we really mean by that. We mean, how can businesses be agile? When we say disruptive, I really mean the flexibility, the speed of delivery Massimo was talking about earlier. But how do you do that without being disruptive to the core business? You can't do that unless you're actually breaking down your software, not only just the technology, but the experience in such a way that you can make these micro changes that have profound benefit to the business without affecting the monolithic whole, if you will. And I think it's just, we've had the experience to where now we're continuously breaking ours down further and further. And I think we have made a tremendous amount of progress under Massimo and Manju's leadership, but we're going to continue that. But it's all rooted in, there is a tremendous amount of business value in that disruptive innovation. But you have to qualify what we really mean by that. It's all about flexibility and ability to say, hey, if I want to at the micro level change one specific business process because you know what, COVID-19 has completely altered something, and you know what, I've got to change my AP process to go against a certain standard. Well, 5 years ago with these types of technology systems, you may not have that option. But now that we have this abstracted view and I can pick and choose all these different services, I can create my own experience. I can create my own process at will without it actually affecting my system as a whole. And I think that's ultimately what we're all striving to get towards. But guys, really appreciate the in-depth conversation. Manju, I'm going to put you on the spot, okay? So we've gotten really, really deep in our technical conversation today. But let's close with your one recommendation to development teams that are starting to look down this path. What's your one recommendation on how you would start?
Oh, okay. So one input I would give for the development teams is that this is not the last time you're going to change. So the technologies are improvising so fast that you'll have to keep changing and adapting, every year, 2 years, right? Because it's coming at us so fast. The recommendation wise, if you have a monolith, then you'll have to look at the overall architecture. What are the high intensity components that you have, and based on that, design the solution, right? And the second thing is that when you have a choice to transition to the microservices and moving to the cloud, you would be posed with a challenge whether you want to make it multi-cloud, or you want to leverage the as much as possible from the native technology from a specific cloud provider. And my recommendation, and the factor that has helped us significantly, is to use the native technology as much as possible rather than trying to build the abstraction, because there are so many services in provided by the cloud providers these days, right? Some of them could be abstracted, some of them cannot be abstracted. It is very hard to abstract some of the services, right? For example, CDN and stuff like that, like you may not be able to abstract them, right? So try to take advantage of the services that are provided by the cloud providers. So instead of trying to just build Docker images and come up with some messaging platform of your like from the open source like RabbitMQ, and manage it and connect them and just say that, oh, I can run in multiple clouds, right? So then you're not truly taking advantage of the cloud platform, right? So you are just building a microservices and wiring it up with something that you will have to ultimately manage as well, actually. So I would say, when you are transitioning into microservices, first is identify, break it down based on the loads and the loads of the future. Keep that into consideration in addition to all the cleanliness in the architecture. And the second factor is take advantage of the services that are available in the cloud platform that you are using, and try not to over engineer by thinking about multi-cloud, right? So then if there is a need, then you can always build that later, actually. So but don't give away the capabilities of the cloud because you just want to be multi-cloud, right? That would be my input.
Excellent. Guys, as always, really appreciate the time, and we'll see you next time.
Okay.
Thank
Take
you.
care, guys.
Bye.
Thanks for checking out the episode, and please be sure to subscribe across our various channels and leave us feedback on our content or any topics you might be interested in. Until next time, stay focused, stay safe, stay happy. Cheers.